So today we have Liam Keenan speaking on the May filtration, THH, and descent properties.
All right, thanks a lot, Sarah. So I guess, yeah, first order of business is to thank Sarah for organizing GROOT. I've certainly enjoyed all the talks I've been to so far, and I'm really glad that there's a great opportunity for lots of people in homotopy theory and algebraic topology to continue talking to each other and doing mathematics, especially in this challenging time. I want to do something a little bit unorthodox and unconventional and maybe inappropriate. And I just wanted to take a few minutes and just say that, so I'm a graduate student at the University of Minnesota. And so I am sort of witnessing a lot of the really horrible things that are happening to peaceful protesters in Minneapolis right now. And I just would say that, if you have sort of not been following this very closely, I would really encourage you to do so. The things that are happening to people of color in the United States is really atrocious and terrible. And it's especially obvious now when you see police sort of pepper spraying nonviolent protesters from their cars as they're driving by. There's many horrible things that are happening, and I just want to take a moment to acknowledge this reality that we are all living in at the moment. And I would also encourage any of you, if you are able, to donate money to a variety of organizations that are really in need of your financial support in this time. People who are, providing gas masks for peaceful protesters, people who are getting food for the communities that have been affected by these protests, because lots of grocery stores have been shutting down because of them. And if you are interested in doing any of this, please shoot me an email and I can send you a list of organizations that really need your support. And so I guess with that, I just want to end this sort of political commentary. I realize this may have not been appropriate, but I feel really obligated to speak about this.
Yeah,
right.
Thank you, Liam. I think it's also really important to bring up the violence against Black bodies in our community, both like now and institutional racism and all of that. But yeah, with that, we can continue on to mathematics.
Yeah, all right. Thank you for allowing me to say all that. I feel it's really important to mention. Okay, so now that we've sort of talked about that, I want to get into talking about the May filtration on topological Hochschild homology and some descent properties of THH and of TC actually that you can sort of deduce as a consequence of this. So I guess maybe the first order of business is to make the kind of standard, maybe the standard declaration, or maybe a declaration that is somewhat standard at this point, that essentially I'm going to be using the sort of Lurie model of spectra. So I'm going to be sort of using infinity categories and all of the language that's developed in higher topos theory and higher algebra, sort of without without making too big of a fuss out of it. And this is the context in which I've done most of this work, but I imagine that without too much trouble, one could adapt these types of results to various other categories of spectra, such as symmetric spectra or something like that. Okay, so let's see. Let's talk about one. So background. Maybe and previous results. Okay, so so I've said some stuff about topological Hochschild homology and topological cyclic homology. I don't want to assume that everybody is a trace methods expert here, and so I want to talk a little bit about what these things are and do so with a little bit of care. So the question is, so what are so THH, which is topological Hochschild homology, and TC, which is topological cyclic homology. And so there are sort of two answers that I want to give. The first answer is the conceptual one. So THH and TC are in some sense approximations to algebraic K-theory in the following sense. And maybe I'll just note that algebraic K-theory here is an invariant of E1 ring spectra, or more generally some suitable type of category. And so what I mean by these things are approximations is that so algebraic K-theory is a functor which takes as input, let's just say, an E1 ring spectrum, and then spits out a spectrum in its own right. And so there are natural transformations. So if K is my K-theory functor, there's a natural transformation to topological cyclic homology called the cyclotomic trace. And then there's a map from TC to topological Hochschild homology, and this map is called the Dennis trace. And so one of the big sort of issues of studying algebraic K-theory is that it is, in general, fairly challenging to compute. And many sort of, so the industry of using THH and TC in a sort of a practical, to put it practically, is essentially to sort of shift the burden of doing some computations with algebraic K-theory, which is really challenging to work with, and sort of shift that over to doing computations with topological cyclic homology and topological Hochschild homology. And so I just want to say a couple of examples of this. So, because I think that these are really important to keep in mind and also just really beautiful, interesting theorems. So the first one is a result that's due to Hesselholt and Madsen. And this says that if K is a perfect field of characteristic P, and A is a finite algebra over the ring of Witt vectors for K, then there's an equivalence between the P completion of the algebraic K-theory of A and the connective cover of the topological cyclic homology, of the P completion of the topological cyclic homology. So this is one such example, and in particular, this tells us, this tells us all of this tells us that we can identify the homotopy groups or the K groups of P complete K theory with the homotopy groups of P complete TC, at least in the connective range. And so the second result, which is interesting, and I think is sort of maybe not so popularized, but there's a result due to Buckstedt, which says that the Dennis trace, once we pass to homotopy, the Dennis trace induces these maps on homotopy groups. Sorry. And so this is surjective, and so in particular, this tells us that, and in here P is prime, and this essentially tells us that the two P minus 1 K groups of the integers are at least as big as a Z mod P, and so this is, maybe I'm not exactly sure to what extent this kind of perspective has been useful in doing like saying more about this story, for example, but this sort of tells you at the very least, like, okay, yeah, I know that these K groups are going to be non-zero and for these particular homotopy groups. Okay, and so these are kind of, I think, two nice examples of how these how THH and TC are sort of used to do some types of K theory calculations. So these are useful to keep in mind. Okay, and so now the second answer I want to give to the question of what are THH and what are TC, this is a bit more technical, and by that I mean correct and an actual definition. Okay, so so let's let A be an E1 ring spectrum, in your favorite category of spectra. Then the topological Hochschild homology of A is the co-limit of something called the cyclic bar construction. Okay, and I guess I should have said this much earlier, but if you have a question about something that I've said, please feel free by all means to just interrupt me and ask, or message the chat and ask there, and I'll try to maybe see those if I can. Okay, so it's the co-limit of something called the cyclic bar construction, and so I owe it to you to tell you what this cyclic bar construction is. So what we can do is we can take A, and also for the smash product over the shear spectrum, I'm writing tensor, and I'll frequently drop that notation because I'm lazy. So it's going to be a simplicial object, and the maps in this diagram, at least, so the degeneracy maps, the ones going sort of to the right in this picture, are all induced by the unit, or by including sort of including that extra copy of the sphere in, because A is in E1 and E1 ring, and then the other maps, the face maps going to the left, are all induced by the multiplication maps that we get from A being an E1 ring spectrum. And so in particular, the face maps, these DIs, are induced by multiplication, sort of in the obvious way that you might think to do this when I is equal to 0 and goes up to n-1, but then dn is sort of induced by moving a copy of, so maybe let me write this out a bit more carefully. Let's see. So if this is one of the terms in the complex, what we do is we use the permutation isomorphism, which moves this copy past the stuff in the middle and comes around to this side, and then we multiply these factors together here. And so there's sort of like, this is sort of why it is cyclic, because you're sort of just multiplying as you go down each of these terms, and then the last term you have to move everything around and go back to the other side. And so this is just what this object is, and there are many places that this is really carefully written down. You can find this in EKMM, for example. You can find the infinity categorical treatment in Nikolaus Schulze, and there are many other places this stuff is written down. Okay, and so there's something else. There's another reason why it's kind of called the cyclic bar construction, is that each of these objects here admits an action by C1, C2, C3, and so on, essentially because you can permute all the factors in these tensor products. And a way to this is in particular an example of something called a cyclic object. So this cyclic bar construction is a cyclic object. And what is a cyclic object? Well, it's nothing more than just a functor, in this case, from a certain category lambda, which is called the cons cyclic category. And in particular, this cyclic category is almost the same as the normal, the opposite of the simplex category, except instead of, you also add some particular endomorphisms which are supposed to behave like these sort of permutation operations, these permutations that are happening in each term. So in particular, there's going to be a self map from n to itself in the concyclic category, and it has to satisfy a bunch of relations and be compatible with the degeneracies and the face maps. But essentially the key point is that this is this is a convenient way to build in the idea of having sort of at each level an action of Cn in your simplicial object. And one of the remarkable features of such things is that whenever I have such a diagram and I take the colimit of it, this thing actually acquires an S1 action. So the resulting spectrum is going to be a spectrum with S1 action, and I mean this in sort of the most naive sense. I don't really, there's I think a pretty interesting story to tell about sort of like equivariant homotopy theory that I'm in no way sort of prepared to talk about, but essentially if you end up working with the sort of sorry, is this a colimit over the functor from, yes, yeah, so right, so yeah, yes, so to answer your question, Elijah, yes it is. Yeah, okay, and so so this has an S1 action, and so in particular, this tells us that since THH is such a cyclic object,